All right. Is that tough?
So I don't know anything. Let's start.
Before we start that, I handed you, no, we'll get to that. Okay, let's go over the test. All right, folks. I'm going to turn this light up here because I might be drawing on the board a little bit. What I'm going to do is essentially try to answer most of these questions for you. I might doodle, and just know that I'm going to explain a lot of these in much more detail. So if I put up something, if I start drawing colloids and things that have charge on them, and I start explaining water surface on a soil surface, then just know that we'll get to that. But I'll try to just kind of fill in the gaps as much as I possibly can with this. I don't want to spend too much time on it. At the end of class, you will take this test again for your own benefit and prove to yourself that you understand at least some of the concepts behind this, okay? I recommend you take really good notes on this, as all of these points will be touched on at some point during the class, okay? Starting with number 1, does anybody want to try to answer this question? So?
It's testing the alkalinity or acidity of the soil to see what is appropriate for whatever crop that you're planting.
Okay, perfect. I'm going to read off the answer I have, which is the technical answer. And then we'll see how it relates to you guys' answers, okay? Basically, pH, where's my marker? pH, right? And it looks like this, right? pH, smaller letter, bigger letter. The big letter is a big letter, capital letter, for one reason. Because the H is equal to hydrogen, okay? And percent or perspective, depending on who you ask, is what the P stands for. And it's really, as the official definition states, it's the symbol for the logarithm, right? Logarithm being an equation. Don't worry about this. I'm going to blow your mind. You don't need to know all this. I'm just letting you know what it means, yeah? Basically, pH is equal to an equation. Okay? It's a mathematical equation that you can decipher the result of based upon data analysis. Okay? The negative log oh, sorry, I had that wrong. The negative log of 10 is equal to pH. You don't need to know that, but I need you to know that pH is not just something we made up out of the sky. It's actually an equation. It's a mathematical equation. And it's telling us how much hydrogen is essentially in whatever media we're talking about. Now, you know that water has a pH, soil has a pH, human fluids have a certain pH. Everything has a pH, right? And it's basically just saying how much hydrogen is in that material. Okay? This becomes very important when we start talking about the charge of things. But pH being one of the most dominant factors when considering fertility, the health of your soil, health of your plants. But anyway, it's a symbol of a logarithm of the reciprocal of hydrogen ion concentration, blah, 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 in grams over liters. That's the official definition. I don't need you to know that. It's basically, like you said, used to express the acidity or alkalinity of a material. Now, when we talk about acids and alkaloids, we're talking about the pH scale, right? Which side of the scale is acid and which side is alkaline? Okay, we got our acids over here. And we got our alkalines over here. Sorry, guys. I'm not the best speller in the world. So, right in the middle, we have what element, or what molecule? Water. Water is the basis of our measurement of pH. So right in the center of this graph, we have water, H2O. Okay? the scale starting at 0, and on the alkaline side, 14. And right in the middle, we have what? 7. Okay? Just know this table, and you should be okay in knowing that on this side of water, we have acids, and on the other side, we have alkalines. Okay? We'll get to that when I break down pH. We'll go through that during the lecture. Okay? When we talk about pH and I say neutral, I mean what? Right in the middle. Okay? If I say something is acidic, right, we're over here. Something's alkaline, we're on that side. Right? Okay. I will get into much more detail on the pH side. Let's talk about the next one. Anybody want to try to answer these? Come on, give it a try. Go ahead.
Soil, hydroponics, aquaponics, I couldn't come up with the third one.
Okay, if somebody looked at the syllabus, we pretty much touch on those on the next class. We're talking about soil cropping, orchard cropping, hydroponics, aquaponics, nurseries as well. Okay? So when we're talking about cropping systems, we're talking about approaches to growing, and really it's approaches to making money through agriculture. Now, where's my eraser? This is going to take a second. I don't want to go in too much detail because I have to touch on this again. Once again. About to say, is this the dry erase? Good. Put up some permanent stuff. That eraser sucks. Sorry about that, guys. Wow, that didn't work at all. What else do I got around here? Something moist. Here we go. All right. Ooh, it smells lemony fresh. Oops. Okay. Next question. If I use a fertilizer that says 10, 51, 2 on the side of the bag, what the heck does that mean? All fertilizers have 3 numbers with dashes between each one on the side of a bag. What does that mean? Everybody want to try it out? Was that?
Phosphorus, potassium, and nitrogen.
Okay, so it goes in the order of, we'll do nitrogen first. So 18, 51, 20. This is the percent in 1 pound of material. One pound of, we'll get into that. Okay, so this will be nitrogen, potassium, or phosphorus, potassium. Okay, NPK. Anybody heard of NPK before? Okay, that's your nitrogen, phosphorus, potassium. It's the amount of those 3 minerals in your fertilizer bag. Now, I'm gonna blow your mind here. I just lied to you. Okay, it's not actually nitrogen, phosphorus, potassium, because nitrogen can exist perfectly fine by itself, right? Nitrogen typically being a gas. But when you bond 2 nitrogens together, 2 molecules together, it can become, actually 2 and then an oxygen, it can become a solid, okay? That's what this is, nitrogen here. But in fact, the P is not P, it's actually P2O5. And the K is actually K2O. Don't be scared, this is just a pretest. We'll go through this in class, okay? And what this is saying is, basically, this number here is not all P. It's not all phosphorus. This is not all potassium. It's actually just a percentage of each. And if I was to say, let's put this over here, 18, 51, 20. See, N is equal to 100%. And the P is equal to, oh, sorry, P2O5 is equal to 56.4% oxygen and 43.6% elemental P. And then K2O is equal to 17% oxygen and 83%. Okay. So, nitrogen, P2O5, and K2O. I break it down. P2O5 only has, of this number here, only 43.6% of that is actually P. The rest of it is filler. It is usually going to be some sort of carbon to balance pH or just a little bit of oxygen. But either way, elemental P, the amount of P that is in the fertilizer is not necessarily this number. It's a percentage of this number. Okay? I'm not going to go any further than that because I don't want to confuse anybody. We will talk about this a lot when we talk about the fertility side. But just know that on the side of a fertilizer bag, we're looking at the three most important elements in plant growth: nitrogen, phosphorus, potassium. And when we start looking at fertilizer recommendations, when we send out a soil sample to the analytical laboratory and they give us it back, they'll say to me, you need to add 50 pounds per acre of nitrogen, 60 pounds of acre of P, and 70 pounds of acre of K. Well, on the side of a bag, that's not NPK. It's actually this, yeah? So you need to do the calculations based upon what they tell you to put in versus what is actually in your fertilizer. I'm not confusing anybody right off the bat, am I? Okay. I don't want to go too much into that. It's pretty intense stuff. But just know that there's some math involved, and that the elements involved in fertilizers aren't just there because they look nice. It's because they actually do something in some function. All right, so we'll get into all the fertilizer stuff when we get to that section, okay? I also, in the last round of classes, pretty much after every slide, I asked the folks if they understand what's going on, and they always said yes. And then I had complaints at the end of the class that they didn't understand what was going on, okay? If you don't understand, I don't know what to say. I'm more than happy to help you out, but you have to be honest with me, okay? If something is totally over your head and it's blowing your mind, raise your hand. James, is blowing my mind, man. I need a different explanation. And usually the best approach is actually finding somebody in the room that does understand it, and they can explain it to you in a different way than I've already tried, and that they actually can fill in the gaps pretty well. As compared to me repeating myself, I'm only taking one approach. I only know one approach. Maybe you can ask somebody else who has full understanding, and I can be there with you guys and hammer it all out, okay? Group learning experience. What is the difference between elemental nitrogen, nitrate, and ammonia? Anybody want to take a stab at this one? Nitrogen is one of the most abundant elements on the planet. Okay? About 80% of the air that you breathe is nitrogen. Okay? Nitrogen is contained in every living plant cell, or every living cell, not just plants. Bacteria, humans, dogs, everything. All made of nitrogen. So it's incredibly prolific in the environment. But nitrogen cannot exist on its own. It has a covalent bond, which means that in order for it to, say, be a gas and buzz throughout the sky, it needs to be connected with another one. When we're talking about elemental nitrogen, we're talking about this. How does nitrogen exist in nature as an element? It can't sit there by itself. It has to be bonded with another nitrogen molecule. Okay? We're talking about, let's see here, what do I got? Now, there's forms of nitrogen in which nitrogen basically bonds with other elements and can exist in many different forms in nature. For example, NO3 minus or NO2 minus. And this one is equal to nitrate. This one is equal to nitrite. And then ammonia is what? NH H2 plus. 2 M's ammonia. Okay. Why is this important? Why do you need to know that nitrogen exists in many different forms in the environment as a farmer? Anybody know?
How do you use it?
Because plants can only absorb certain kinds. And so if you're talking about fertility and you're talking about using nitrogen to grow your plants bigger, you have to know that plants can only absorb certain kinds and certain kinds are not absorbable. Is that a word, another one I made up? So, all three of these are plant uptakeable. These three here. Plants can also absorb this gas out of the air, but they cannot use it unless they give it to a set of microbes that it contains within its plant structure. The microbes then turn it into one of these, and then the plant can take it up. Okay? That's called nitrogen fixing. Certainly helpful when you're talking about ground covers, you're talking about plants you want to plant next to your plants that actually add nitrogen to your crop. How wonderful is that? So they do exist, yeah? But through the help of microbes. Nitrate exists, I'm going to skip over nitrate, but nitrite exists in nature usually for a very, very short period of time. There's some gas exchanges, there's lots of things going on in the soil, and what happens is ammonia somehow finds its way and becomes nitrite, and once nitrite runs into these wonderful things, microbes, it gets turned into nitrate, which is the most desirable form of nitrogen for plants. If they could choose, they would want this. In nature, as soon as nitrate is floating around in the water surface of the soil, as soon as it runs into a certain set of microbes, boom, it gets turned into this. So it's very limited in its existence in the soil. Ammonia. Ammonia being also very plant uptakeable, but also, man, I can't spell, water soluble. Okay? So just filling you in, as far as nitrogen goes, it's pretty specific to nitrogen, that there's many different kinds of nitrogens that plants can associate with, but only at certain phases of the nitrogen cycle can plants uptake that element. Okay? That's all I want to express with this question. Okay? We'll get much more technical later. Who wants to try to answer number 6? Come on. Did we?
Yeah.
Crap, sorry. Oh, let's do number 3 there. Describe what a cover crop is and why you use them. Name 3 commonly used cover crops. Davey, got an answer? Okay, good call. Okay, cover crops are crops that you plant over an area for a certain purpose. Depends on what your purpose is. Now, Many people will use cover crops to prevent erosion. It stops rain hitting open, dry soil. Rain hits it, breaks it into pieces, and then floods it away, disappears. What happens if you have a nice clover field over that exposed soil? What happens then? The roots hold it in, the plants absorb that water, the soil stays, so it's certainly a technique to be able to retain soil and soil erosion. They can be nitrogen fixing. So you got perennial peanut, or you have sun hemp, which will actually take nitrogen out of the atmosphere, put it into its cell structure, give it to a bunch of microbes that it keeps down in little nodules in the soil, and then it then creates nitrogen, which it absorbs. And then you can either till that in, or as it starts to break down, like perennial peanut, will then give that nitrogen back to your crop. So nitrogen fixing, certainly a good reason to use cover crops. Any other reasons? Weeds? Keeps weeds out, right? If you plant plants there that you want there that will choke out weeds and gives nitrogen to your crop, how fantastic is that? You don't have to mow, you don't have to worry about weeds, yada, yada, yada. Okay? So, cover crops, certainly useful, and we will talk about that in class. Oh, some examples. Sun hemp, clover, perennial peanut. I think I just said those three. You can do oats. You can do duckweed. There's tons of things you can do. Okay? Where are we at? Number 6. Who wants to try number 6? Come on, somebody take a stab at it. I want to hear what you say. Papayas? Okay. Mac nuts?
Coffee,
Uh-huh. Anybody else?
taro.
Taro? Any other guesses? It's a trick question, by the way. All right. Trick question. I'll talk about this later when we talk about our crop selection, but you might want to write these things down. The best legal crop to grow in Hawaii is one that meets a market demand. Okay? One that grows within your environment. Got that? One that is cost effective to grow. Can it be grown sustainably? Or do you have to dump chemicals all over it? Is it easily transformed into a value-added product? Like, are you taking your tomatoes and turning it into salsa and selling it salsa for $6 a bucket? 2 tomatoes for $6. A little bit of onions, some cilantro, that's added value. Can you take your product from the ground, turn it into a value-added product, and then sell it? Does it have a long shelf life? Papayas? Not really. Squash? Yeah. And how much can you get per pound of squash on this island? Sometimes $2, $3, $4 a pound. Sometimes the squashes sell for $11, $12 a piece if they're organic. And you could let that sit on your shelf for a month until you sell it. Okay? Squashes might be a good way to go. Just an example. It might not work in your environment, so it might not be the best. Okay? Moving on. One that you can receive top dollar for. Now think about this. Is it a crop that, say, a restaurant like Cafe Pesto or the hotels will buy? Because those guys, you literally walk in and you say, I want $7 a pound for that, and they say, okay. If it's pretty, that's all they care about. And can you get it to them on a consistent basis all the time? If that's the case, $11 a pound. I don't care what, I didn't even hear what you were charging me. They want it. So are you able to sell it for top dollar? One that allows your farmer to grow a crop that they are passionate about. If you don't care about your crop or really interested or pretty much understand the whole structure and the reproduction and all this stuff, if it's not doesn't make your head buzz about how awesome this crop is, then don't grow it. Because people that are trying to buy it from you, they see that sense of excitement or lack of. Okay? One that is disease pathogen-free, super important. Go ahead and restart it. That's fine.